Alrighty, so we looked at the law of cosines today and figured that out, and I have them listed here again, meaning in the English letters A, B, and C are the sides, the lengths of the sides, and the Greek letters alpha, beta, and gamma are the angles. So what we're going to do is we're going to solve this triangle using the law of cosines. So the first thing I'm going to do is solve for B. Now, because that's the angle that I have, I'm going to go ahead and find that one. So I'm going to use this formula, and so I have b squared is equal to a squared, which is 13, plus c squared, which is 6, minus 2 times a times c times the cosine of my beta angle, 20 degrees. So I get b squared is equal to 169 plus 36 minus 2 times 13 times 6 becomes 156, and I still got to multiply that with cosine of 20, and so I get 205 minus, and this becomes approximately 146.592. I'm going to keep that in the calculator and multiply or subtract it from 205, and I'm not going to round it. I'm going to subtract the exact number, and I get 58.408. And when I take the square root of that, b is equal to approximately plus or minus 7.64, but we're only going to use the positive because we're just referring to a length of a triangle. So that's my b. So now that I have that side, now I can use the law of sines to find the other parts of the triangle. So we're going to have sine of gamma over c is equal to sine of beta over b. And the only one I don't have is that gamma. I know c is 7.64 is equal to sine of my beta is 20 over, oh, I'm sorry, this should be the 7.64, and my c is 6. Hope you caught that. So to simplify this, I get sine of gamma is equal to, and if I multiply 6 to both sides, that gets that angle, that sine by itself. And now I can use the inverse sine. So gamma is equal to sine inverse of 6 sine 20 over 7.64. And at this point it's just typing it in the calculator correctly. It is kind of weird because there's a sine inside of this sine inverse, but you can still do that. You have all the parts to that in order to type that into the calculator. And so I get gamma is equal to 15.67. If you're rounding to the nearest degree, which is what the book does here, it would be 16 degrees. Just pay attention to what the directions say to round to. And I'm going to move that up so I can go ahead and find alpha now. Now that I have gamma and beta, I can do 180 minus 20 plus 16. So that's going to be 180 minus 36 becomes 144. So those are my three missing parts, and I've solved the triangle. So for this one, I'm not given any angles, and I have all three sides though. So I'm going to draw a triangle now. It's not necessarily going to be to scale because I don't know what the angles are. But I'm going to label this A, we'll label this B, and label this C. So to find these angles, we're going to use the law of cosines still. And you could really pick any of the forms of it at first. So I'll use the one we solved for, a squared. So that's going to be 8 squared plus, or I'm sorry, 8 squared equals 6 squared plus 7 squared minus 2 times 6 times 7 times the cosine of alpha. Remember, this angle should be opposite this side that you started with. So I'm going to simplify, and I'm trying to solve for alpha, so I got to get that cosine of alpha by itself first. You can multiply these out, or you can just keep them as the squared. I'm going to go ahead and multiply them out, and this becomes 2 times 6 times 7 is 84 cosine alpha. So I'm going to here subtract. I'm going to subtract 85 from both sides. And what I get is negative 21 is equal to negative 84 cosine alpha divided by negative 84. If you didn't notice, I subtracted 85 because that's these two combined. So I have 85 minus 84 cosine alpha, subtract 85. Negative divided by a negative becomes a positive. So I have, and that becomes, reduces to 1 over 4 or 0.25. And we're going to use the decimal. That's okay here. And because I need to find that alpha, now I'm going to use the cosine inverse cosine of 0.25. And that gives me alpha is approximately 75.5 degrees. Now that I have that angle, now I can use the law of sines to find one of the other ones. And I'm going to go ahead and solve for beta. So I have alpha, so I have sine of 75.5 degrees over, and that's my alpha, so the one opposite is 8, is equal to sine of beta over the side opposite is 6. So if I multiply both sides by 6, I have 6 sine 75.5 degrees divided by 8 is equal to sine of beta. And again, so now to find beta, I'm going to use the inverse sign of 6 sine 75.5 over 8, and beta is approximately 46.6 degrees. And then to find gamma, now that we have both the other two angles, I can do 180 minus 75.5 plus 46.6, and that's going to be 180 minus 122.1, which means gamma is 57.9 degrees. And now I found all three other angles, and I've solved the triangle. So you have to use the rules that you have and go one, sometimes depending on what you have, depends on what you can use. So get in the habit of trying to figure out what to use when you have what information. Alright, here's a good one. What do you call a man who rolls in leaves? Rustle. Get it? He's rolling around, rustling leaves up. Russell.